Good evening and welcome to the Q&A session 9 from the chapter of Semiconductor Devices and Circuits. The topic is the calculation of free electrons and hole concentration in a semiconductor. And based on this topic, I have one question from the NCERT book. So this question is available in the NCERT book. And the question here is, a pure silica crystal has got 5 into 10 to the power 28 atoms per cubic meter. It is doped by 1 ppm concentration of the pentavalent arsenic. So if the intrinsic carrier concentration is equal to 1.5 into 10 to the power 16 per cubic meter, here Ni is the intrinsic carrier concentration. So if Ni is equal to 1.5 into 10 to the power 16 per cubic meter, then calculate the number of holes and electrons. So here the concentration of the pentavalent dopant is given in ppm and this is equal to 1 ppm. So if I want to find the concentration of the pentavalent dopant, that is arsenic, in atoms per cubic meter, then it can be found by multiplying the ppm concentration by the total number of atoms in this pure silica crystal per cubic meter. So the total number of atoms per cubic meter in the pure silica crystal is equal to 5 into 10 to the power 28. So now 1 ppm is equal to parts per million. So this will be equal to 5 into 10 to the power 28 divided by 10 to the power 6. So this gives us 5 into 10 to the power 22 atoms per cubic meter. Now, since this pure silica crystal is doped by a pentavalent dopant, therefore we will be getting an N-type semiconductor. And in the case of an N-type semiconductor, each pentavalent dopant atom generates one free electron. So here the total number of atoms per cubic meter is equal to 5 into 10 to the power 22. So the number of free electrons will be equal to 5 into 10 to the power 22. Now we have to find the number of holes. So for finding the number of holes, we will be using the relation, that is Ne into NH is equal to Ni whole square. So this is a relation between the concentration of the free electrons, holes, and the intrinsic carrier concentration in a semiconductor in thermal equilibrium. So if I use this formula, then from this formula, the number of holes, that is NH, will be equal to Ni whole square. Here NH will be equal to Ni whole square divided by Ne. So the value of Ne is equal to 5 into 10 to the power 22 and Ni is equal to 1.5 into 10 to the power 16 per cubic meter. So here the number of holes will be equal to Ni, that is 1.5 into 10 to the power 16 whole square. So this will be equal to 2.25 into 10 to the power 32 divided by 5 into 10 to the power 22. So this is equal to 0.45 into 10 to the power 10 per cubic meter. And here the number of free electrons is equal to 5 into 10 to the power 22 per cubic meter. So the number of holes can further be written as 4.5 into 10 to the power 9 per cubic meter. So the number of free electrons per cubic meter will be equal to 5 into 10 to the power 22, and the number of holes per cubic meter will be equal to 4.5 into 10 to the power 9. So in the next session, I will be coming up with a different type of a question from the topic of intrinsic semiconductor. So till then, have a nice day. Bye.